the new file, and the second is the open file menu item. And in this probe, we suppose that user will click the open file one. So if they do so, the main process will then render the native system window for user to choose which exact file they want to open. Once user done selecting, according to their operation, the main process may return back a string of file paths to the renderer process, or it may do nothing at all if user just click the cancel button. So that's the workflow. The important contents of this probe are how to communicate between main and renderer process, and also how to create and display a native context menu, and finally how to render a native system window. So first, the main process will use method of electrons menu module to create an instance of menu at line 451. Right now, this menu instance has nothing inside. And the code from 452 to 465, two menu items are created and appended to that menu instance. And as you can see, each menu item has properties like label, ID, and of course, the functions to perform when someone clicks it. And the focus of this probe is the second menu item. So it's open file one. If user clicks this menu item, the main process will execute the function called open dialog, which I will introduce later. Now we have this. Now we know how to create the context menu at the main process. Let's say how to establish the communication from renderer process to main process, so that the main process knows it's time to display the context menu on the GUI of that renderer process. Basically, at the renderer process, when user clicks the button, line 17 will be executed using the sync method of IPC renderer module provided by Electron Framework to send the message to main process through the channel called showNav context menu. So the main process at the same time handles this message by using IPC main module. The job of the IPC main module at the main process is to handling synchronized and asynchronous message sent from renderer process. So in this example, whenever a new message arrives through this channel, main process will execute the main process will call pop-up function of the menu instance to pop up to display that context menu on the GUI.
So, does the renderer process always talk to the main process?
No, whenever it needed. I mean, because in this probe, user clicks some button on the renderer process.
Yeah.
So at this time, we need the renderer process to talk to the main process to display that context menu.
Yeah, the reason I asked that question is, I don't see anywhere that you're indicating the main process is the one. You say send sync.
Yeah.
But how do I know that's being sent to the main window, the main process? So there's some internal routing going on that I don't know about.
Actually, it's this IPC renderer module and the IPC main module. Those are modules of a class named emit message of the Electron framework. So when you use method called send sync, it will send message from the renderer process to that main process. So it's like you said.
There's more than there's three processes running at least, right?
No, just two. The renderer and the main process.
Oh, okay.
Yeah. Okay. Now let's suppose user click this menu item, and
I thought your first diagram showed three processes running.
This one.
I'll go back one more. Oh no. Okay. Yeah.
No, this.
Okay. Renderer process. Oh. Okay.
Yeah. This is just.
Yeah. I guess.
Yeah.
Sorry.
It's okay.
Yeah, that's okay. He started, so you'll just go after him. Thanks for letting me know you're here.
Yeah, after this, we suppose user clicked the menu item, this one, and the open dialog function get executed. Inside of the open dialog function, the main process will call show open dialog method of the dialog module of Electron provided by Electron framework, which will help us render the native system window. And at line 469, we specify that this system window can open both file and directory. And in the next line, we also specify an array of file types that can be selected or displayed. And in this application, which is just the markdown, the result of user's operation will be sent back to the callback function at the argument files. So this callback function can check if user select a file or they just click the cancel button. If they do select a file, the main process will then use send method of this web content module to send message back to the renderer process. So that's like the communication between main process and the renderer process, both sides. And in this example, we send the file path back to the renderer process.
Now, all of these methods you're calling are really, they're provided by the Electron framework.
Yes, yes.
But the Electron framework probably doesn't provide handling of the entire platform API. It's just some part of it.
Yes, some part of it.
Is there a way for you to add? So let's suppose I want to use some other part of the framework out of Electron. Can I? Is there a way for me to?
Yes, it is, but in this probe, I didn't prepare.
That's okay. I didn't expect you to do it. I'm just asking if you.
Yeah, yes, it does. It does. So right now at the renderer process, it will again use the IPC renderer module to listen to the same channel and receive that file path. And with the file passing head, the renderer process can do all kinds of operations. Like in this probe, we are going to open that. And that's the explanation of the code of the workflow. Now I will do the demo. As you can see, the window here is a renderer process, as you can see. And when I click the button here, this is the context menu, which belongs to the main process. And I click the menu button, open file. As you can see, this is the native system window provided by Electron framework. So and I will see the result. That's the result of the probe. Any questions so far for the first probe? Okay, next one. Next probe is add Google service, Google Photo service. This probe is going to demonstrate how to make user authorize this application so that later the application can upload image to Google Photos for user. The workflow this time is a little bit complicated. First, I need to mention there is only one main process. This graph is just for you guys to easily see those two renderer process. So I have to separate the main process into two parts, but it's actually just one main process. And there is two renderer process, first one and the second one called Google Auth 2 renderer process. How this works is first, this renderer process will start a local server using Express module and listen on certain port. And when user click the button on the GUI of this renderer process, it will generate an authentication URL and send that URL to the main process. The main process then, with receiving the URL, will create a browser window instance, which is also a renderer process to load that URL, which is the Google Auth 2 renderer process. Within this renderer process, user can follow the step of the authentication and make their decision to authorize this application or not.
Is the framework doing the
authentication?
No, not the authentication, but doing the handling of the RESTful API that Google is providing for that authorization?
No.
Or are you writing that?
No, I'll use the auth2 module provided by Google to do the, to mangling around the RESTful API. That module will do all the job for me.
Okay.
Yeah.
So that module, is that a Electron module?
No, that's a module provided by Google.
No, I understand.
Yeah.
I'm trying to understand. So Google is really providing you with a RESTful API to do authorization, right? That's
Yes.
really the way it works.
Yeah.
Right?
Yeah.
Now, somebody is making queries into that RESTful API, okay, and presenting information to your application, and I'm just trying to find out who's doing that handling of the RESTful API. Is it Google code?
No, I code it. I code it.
So you wrote it?
Yeah.
Okay.
At the end of this Google Auth2 renderer process, Google will use the redirect URL provided by us to send a redirection request back to the local server we just started, so that this renderer process knows it's time to send a message to main process to close that Google Auth2 renderer process. And of course, this renderer process will try to find the secret code with if the user give the authentication to the application, some secret code will send back with the request send back in the request code from Google. Yeah. So this renderer process will try to figure that out.
So the framework is really using AJAX calls to.
Yeah. Yeah. So the important contents of this prop are how to use the Auth2 module provided by Google, and how to use Express module to start a local server for receiving returning information from Google. First, at the upper renderer process, we will use a method of Express module to start a local server and make it listen to port 3000 for connection. And of course, this renderer process will load bunch of modules, which includes modules from Google. And at line 6, we create an instance of auth2. And in order to create this instance, we have to provide 3 arguments. Client ID and client secret can be found at this link when you create your own application on it. And this redirect URL, it has to be a valid URL of our local server, so that Google can then send back, send some information back. So and we can catch it by using our local server. Now the server is running and our auth2 instance is created. Let's say how to generate the authentication URL. Basically, all we need to do is to call generate auth URL of auth2 instance and provide some argument, access type and scope. Access type can be online or offline. The difference is that online will eventually only return an access token with time limitation. So when this token expires, user has to go through the authentication process all over again to get a new one. And offline, on the other hand, will not only return back an access token, but also with a refresh token that has no time limitation. So in this case, application itself can use this refresh token to ask for new access token whenever the old one expires. So in this way, so this application is going to use the offline model, so that user don't need to worry about repeating the authentication process again and again. Scope. This application only needs 2 scopes. First is the authentication to read user's email address, and the second one is to manage the data of user's Google photo. When this authentication URL is generated, we then use IPC module send sync again to send that argument to the renderer process. And here we can see with the after receiving the argument, we will pass it into a function called create auth window. And this function is basically create an instance of browser window, which is a renderer process. It's Google Auth2 renderer process, and load that URL. And now the responsible is for Google. You will follow a step provided, authentication step provided by Google.
And this is the second render process that you're
Yes,
talking about.
yes. First is the upper render process, and this is the second render process. And bunch of steps, happens after this function. And let's say at the end of the render, at the end of this render process, at the end of this render process, user give the authentication to the application, and Google send the redirection request back to our local server. Our renderer process that starts a local server can catch the information using get method of the express module. And as you can see here, at line 15, we'll send message immediately to main process to close that Google Auth to renderer process. And from line 16 to 23, maybe, we try to find the existence of that secret code. And if it does exist, we will use that secret code and the get token method of the auth2 instance to get the refresh token and the access token. And now let's see the demo. Now we click the button on the, this is the renderer process, the first renderer process. We click it. Oh, yeah. We click it, and before this window closes, this is the second renderer process, which is a Google Auth2 renderer process. Before this window shows up, we generate that authentication URL at the, somewhere else. And let this window load that URL. So right now, this window is controlled by Google. I mean, the step is controlled by Google. And I will add this, and it says blah, blah, blah. And view your email address and manage your photos and videos. We allow. And now, we see our account adding to, into the application. Means we authorize our application, our account to this application. Any questions so far? I do provide a little video for each demo, so you guys can watch it later if anything wrong with the video catching. The third probe is the upload image to Google Photos, which is a follow probe of last one. This probe is going to demonstrate how to use the refresh token we just get and the AXL module to upload image to Google Photo. And when we have those URLs of the uploaded image, how to write them into the system clipboard using Electron framework. The workflow this time is quite simple. As you can see, we get the access token using refresh token and use AXL module to make HTTP requests to upload these images and eventually write those URLs into the system clipboard. Important contents of this probe are how to use AXL module to make HTTP requests and how to get access token by using refresh token and experience promise feature of JavaScript, and finally use clip module of Electron framework. So in this first function, we'll have this argument refresh token. At the first part, we create a new instance of AXL with custom configuration, which are base URL and headers. You can follow this pattern to do your own to create your own AXL instance to make HTTP request. And then the second part, we also compose the data that will send along with the request, which contains client ID, client secret, refresh token, and grant type.
So is that really putting JSON in the body of the message? Is that what's happening?
Yeah, you can consider it like that, but it's not JSON. Within the request.
But some encoded form is
yes,
going into the body.
It's this one. It's this one. It's not JSON. When you print it out, it's not JSON.
Okay.
So when this AXL instance is created and this data is composed, we'll perform a post request using that AXL instance to this path with the data we just composed. And if the request succeed, the code in the then block will be executed. If else, the code in the catch block will be executed, which is error handling. I didn't show it. And this then and catch mechanism is what is also known as promise, which I will introduce in the next slide. Back into the then block. If we do get the access token from the response data, we'll pass it into the function that try to upload the image for us. If this upload succeed, we'll have the URL of those uploaded image and pass the URLs into the function that try to write them into the system clipboard.
So you're defining a lambda in JavaScript.
Yeah, kind of like that.
I've never done that.
You should try it. It's really exciting.
I like lambdas real well, as you know from class.
Error function.
Yeah. Now let's talk a little bit about the promise. A promise is basically a proxy for a value not necessarily known when the promise is created. So you can, how do you say it? So you can associate the handler with an asynchronous actions eventual success message or failure to it. And also you can see here, a promise is passed with two arguments, resolve and reject. Those are both functions. So if everything works out, the resolve function will be triggered here, as you can see, and return success information and resolve the promise. If it encounters any error, the reject function will be executed, return error message, and reject the promise. And promises can be chained together to perform certain logic. As you can see in this function, the return promise will be resolved only if all those promise get resolved. And if any of those promise is rejected, then the return promise will be rejected, so that our application will get some error message instead of the URLs.
Question?
Sure.
Yeah, why are you putting
I really want to answer this question, but I forgot it.
you use async if you're doing await in your code, but you're just using the promise API.
Oh, the reason why I have this async, I think it's to keep the order of my uploaded image into the right order, because I can select multiple order to upload, right? I want to make them. I want to make sure I get the how to say that. I have the return URL as in the order as I uploaded them.
You don't want to block the node thread.
No, I don't.
That's why async is here, right? It's just because you're trying not
Yeah.
to block the node
Yes.
thread.
Oh, yes.
It's really important that you don't block that node thread.
I know,
but-
but he's not. That would be if he used await inside the body, but he's just using the promise API. He's just doing promise then and then catch and.
Yeah, I understand your question, but I really forget why I put it here. I mean, I explained why I want to use this feature, because I want to keep the upload in order. I may upload several images and as a certain order, and I want the return URL as the same order.
I see, yeah. I see your question now.
I don't know how async.
Because you're just queuing up the images to go. You're
Yeah.
not sending them here.
Yes,
Is that
yes.
right?
So
So
maybe
you-
I should do it.
So probably you don't need the async.
Yeah.
Probably no harm either. That's using the web worker, I assume,
Now in this step, we assume that application has the return URL and it wants to write them into the system clipboard. All it needs to do is to call write text method of the clipboard module of Electron framework and pass those URLs into that function. Then the Electron framework will do the rest job for us. And Let me do the demo. First, I'll select for images. Select the server I want to upload to. Now Markdown text is already written into the clipboard. Now you have it. Let's see. That's a demo of the third one. You guys have any question?
I'm not sure I understand what happened here.
Oh, which exact step?
So, I don't understand why it was waiting.
This is uploading.
But so my mental model, so go back to that code again for a minute. My mental model here was, I look at this, and my mental model is that you're queuing these requests to upload.
Yeah.
And Electron is taking care of the upload. True?
Kinda.
And so I would have expected Electron to be doing that asynchronously so that we wouldn't see the wait. Or is it the promise you're waiting on?
The promise we're waiting.
Promise is what you're waiting on.
Yeah.
Okay.
This promise is basically an asynchronous message. You're waiting for the return URL. Yeah, question?
This is regarding that browse window function that you used, the previous one.
Which one?
The browse window function. Yeah.
This one? Yeah.
So this browse window will create a new window which is like a complete browser.
Yes,
It
yes.
can work like a separate one.
Yeah, like this is a renderer process, a separate renderer process.
So Electron provides this function for us, and
Electron, yeah.
so this browser window can be like put over another window. Like if you have one
Yes.
page,
Yes.
so it gives us the control of having. I mean, we can move it anywhere inside that.
Yes. Yes. Yes.
This relates to his project.
It's totally okay. I mean, you can have browser window like you can have browser window like this one, which will block the parent window. As you can see now, the browser window you cannot click the close button.
Because it's modal.
Yeah, because this one is model, and of course you can create a totally separate browser window that has nothing to do with the first one, and do all the operation.
So if this is created, then I mean, for example, if I'm creating an iframe over the HTML page, I won't be. If I create an iframe over the HTML page, I won't be able to open certain sites like maybe take some Facebook or Instagram or anything. It'll be all blocked.
Of course you can.
Yeah.
Yes, you can.
No, if we open it in an iframe, they don't give us the authorization. It's a violation of process.
Oh
if
yeah,
you're trying.
that depends on the website you are
Yeah,
talking about.
that's why.
Yeah.
So
if
if
they
this-
really consider the security, they won't let you open the website in the iframe. Yeah.
So how does this work? This opens everything. This browser window can open everything.
Because that's not the iframe. That's a totally
I'm
broad.
asking. This opens everything, right?
Yes.
This isn't the browser running HTML code. Electron framework.
Yeah. Any other
And it
questions?
has its own.
So you write the GUI in Markdown.
Yeah, I'll write it in pure HTML, CSS, and JavaScript.
Oh, okay. Because I saw these are because I saw you open from the MD. I assume
That's a Markdown file I opened.
that's the GUI or the GUI.
That's a file like the TXT. That's just the content I opened it with. So. Summary. In the first probe, we get to know how to communicate between both main and render process, and create and display a native context menu, and of course render a native system window. And in the second probe, we get to know how to use Auth2 module provided by Google, and use Express module to start a local server for receiving the return information. And last one, it's a little bit confusing for Professor, but I think we talk about how to use AXL module and how to get the access token by using refresh token. Yes, and experience some promise feature. And finally, we use clip module of Electron. And that's my probe presentation. Any questions?
Any more questions for Hayu? We've already asked you quite a few.
Yeah.
Thank you. Nice job. I think that was a very nice example of a probing presentation. I like the way you did it. Nice initial summary, and his materials were very good. Yeah, let's see if we can. So, plugged in the HDMI. Oh, no, okay, good. Let's see, I just get close enough to it and it goes on. Lucky for me, I didn't have to figure it out. Doesn't work again?
I got leaving.
Oh, I gotta stay up.
It's like an aura.
Yeah. These guys have synchronization problems. So I just, sometimes it's just a connection. You need to type very gently.
Good afternoon, everyone. My name is Yao Dong Wang. My probe presentation is for my project, the Bitcoin arbitrage bot. Here is my content table. First, I will review the architecture to refresh your memory about what's the project about, and then we will probe three different probes in this project. Here is my revised architecture. It goes from the left to right. First, the Go project, the Go bot will collect the data from the Internet REST API, and then it will send it will post this data to the Node.js server. And Node.js server is responsible for put them into the MongoDB, and then after that, it will respond to the client, the direct data request to provide refresh the data. So here is the whole architecture, and here is the activity. From here to left is a job that Go client charge for, and from here is a Node.js and here is a little complicated. Here the routine will collect the data and make a determination whether there's a profit. If there's a profit, it will go to another routine called trade simulator. The simulator will generate another routine to complete the transaction. Why there's one more routine? Because this task could be very time consuming. So after all this done, the rest post routine, here's one more, another routine will collect all the data and post them to the node server. So first, I want to talk about the Go concurrency pattern and give you some basic concepts in case you don't understand what I'm going to talk later. The concurrency in Go will refer the concept like routine and channel. Routine much like the threads in C++ or C#, and the channel is like a very how this routine can exchange or communicate to each other using the shared data. And inside the channel, there's a buffered and unbuffered two kind of channel, and also the timeout and the ticker is also a kind of channel. So if you use the ticker, actually you are using the channel to communicate between different routines.
Each Go routine is a separate process, I assume.
Yeah.
And the channel is really inter-process communication.
So here I will give you a little demo about this basic.
Set up the demo, then we'll worry about. Once you get the demo set up on your computer, and then we'll wiggle the. Find this thing.
So here's my whole project in VS Code. There's a GoBot and there's a main stack part. So let's first check the GoBot project. Here is my test stuff. When you want to do some test stuff in the Go project, you just name it something underscore and test. Then you make a test. It will run your test stuff. So let's have a look at one by one. The first is the test the unbuffered channel. Here the goal means I kick off a new routine to run in the background, and here I make a channel. Here I make an unbuffered channel, and and this routine will fetch the data from the channel and display it to you. And in the current routine, it will put this string into the channel and give you a reply. So let's have a look at what's the response. So receiver says hello, the sender says hello, because the receiver gets the message from sender. So this is the unbuffered channel. If I send more data to the unbuffered channel, it will get the current routine blocked. So let's try it. Okay, it's blocked. The sender is blocked. It sends out the second data, but no one else.
There's nobody to pull it out of the channel.
Put it from the channel, so it is blocked forever. So this is a kind of a bug called routing leak. So the second, let's check the buffer channel. So the buffer channel here, the number is the capacity of the channel. So it means the buffer is 1. It can hold 1 data in the channel. So for now, if I send 2, if the current routine send 2 data, it won't get blocked because there's a buffer of 1. There's 1 buffer. So the second test channel buffer here. So the sender send out hello, and receiver get hello, and the sender send the second send out the second hello. And its end here is passed, so it's never blocked. So that means that the buffer channel will lose it's a little more flexible. I mean, not as strict as the buffer channel. So here is the select channel. So what if I don't want to my okay, here's one more. Sorry, here's one more for the buffer channel. If I send more data to the buffer channel, because my buffer is only 1, if I send 2 into the buffer channel, the routine will still get blocked because the buffer is full. So let's try it. Okay, for the second test step, the routine is stuck here because the buffer.
So this is like a bounded queue that blocks when it gets full.
Yeah.
So as long as it isn't full, you can keep, and it won't block.
So the next question is that I have a buffer channel, and how I don't. So if I don't want to block it, what can I do? So the Go also offer you the option. You can use the select case to multiplex the channel. It's very like the switch case structure. So for the last test step, even though although the buffer is only 1, but it never get clocked, but get blocked because we have used this CR case. So in this output, it will output out the even number. because for the our number it's in it's used for read from the channel, and for all the even number it fetch data from the channel, so it's never get blocked. Anyway, so I want to demo this because just to show you that the Go language offer you very flexible option to how to manipulate the channel between the routine. So so next is to give a picture of how many routines are there in this project in my program. So because I have investigated 10 internet exchange APIs, so there are 10 tick price API, and there's a simulator to simulate the trading process, and there's a post to node in charge of post the data from the Go bot to the node servers, Node.js server, and there could be more routines that to conduct the delayed transaction. So there are so many routines, right? So how can they work together? I use the ticker every here's the ticker every 6 seconds. Why I use the cycle 6 seconds? Because after the investigation, I found that 6 seconds is much safer to use the exchange API, because all these RESTful API they have the data access limit. They don't allow you to use that data too frequently. So here I want to talk about what I want to talk is all the tick routines. They are synchronized by the ticker. So when the ticker starts at 6 seconds, or then the 12 second, they will start the task. And for the ticks simulate routine, it's also synchronized. So, but for the post to node routine, it's not synchronized by the ticker. It is just do its job as quickly as possible. So let's have a closer look at how does they work. Okay, so let's first have a look at these routines and the simulator routine. This routine will fetch the price data and then send them to the channel. And the number 12 is the simulator routine here. It is responsible for collect all this data from this price routine, and then start the simulation. I mean here start the simulation. When the simulation starts, it will generate a delayed transaction. it will kick off a new routine here. So there's a interval between the cycle. So what happened here? For this the tick routine, for the tick press routine, he will keep asking, is my data received by a simulator? Because we are using the unbuffered routine, so it's blocked here. It will keep querying whether my data is pulled by this guy. So do I.
So you're not blocking, you're polling the channel to see if you would block if you said anything.
Yeah, it will block. Yeah. Here's another case that my data is received, so I lost my job. So this guy's time life is over. So the simulator routine will fetch all the data from the channel, from the unbuffered channel. Then what's happened here? The simulator routine at the ticker will start simulating, and if it will make a determination if there's a work occur. If it is, it will dispatch it to a new routine called transactor. It will kick off a new routine. So the transactor will do the time-consuming job. Now, when all this done, they will send the result of the data to the post to node routine. So what's happening here? It's at the team ticker, and it's at the ticker. So I have finished my part and send all the price to the buffer channel, and my job is done. And he calls it a day. So for the transactor routine, okay, finally he finished his tedious job then, and send the result back. He also sends them back to the buffer routine. So when they send them to the buffer routine, then the post to node routine will pull out the data from the buffer. If there's no mail in the, let's call this the mailbox. If there's no mail in the mailbox, this guy will block here. But if there is, he will pull all of them one by one, then send them to Node.js.
I don't understand what the transactor is doing.
Transactor will doing the it will simulate the network delay. For example, here is only 6 seconds cycle. The network delay could be
So
1
you're
minute.
giving it some latency to see what happens with the price changes.
Yeah. So about them is my design, but that design it didn't come out at the first place. So before that, here is my alternative solution. The simplest one is the simplest solution is that let everyone do their job at the ticker at the tick time. For example, like this. So we don't do this. When it's at the tick time, he fetch the data from channel and start simulating. So what's the problem in here? For example, because we're using the exchange REST API from the internet is not reliable. The API could deny your request. It could down. So that means that this routine could never fetch, could be failed to fetch any data back. So if this happened and you do it this way, you do it, you fetch the data at this time, this guy will stuck here forever because the number 2 routine never gave me the data. So why it's stuck? Because we were using the unbuffered channel, and the unbuffered channel will cause the block. So what about using the buffer channel? Because if we use a buffer channel, the block is gone. But it also doesn't work. For example, if this guy at first is done, but then it recovered and then send the data to the simulator. But the simulator has already collected all the data from the buffer, so it's too late. It missed this guy's mail. So based on this problem, I abandoned this design and finally formulated my final design. Is there any problem with? Is there any question with?
I was wondering, because these are all independent processes.
Yeah.
So why do we need to sync to a certain
Because when I use the sync, I can make a decision in time to determine whether I trade or not. I make the profit from the arbitration.
So that's the simulator, right?
Because because the price data is changed time to time, so you have to make a decision in time.
Yeah, I know that part, but for instance, it looks like there's only one process calling the shop here. All the other doesn't have to sync to provide information, and as you said, it's not reliable enough. Mm-hmm. So why sync it in the first place? Because one of the process doesn't provide a data in time. Why sync it in the first place? You can just provide the data to the simulator independently. And then if simulator constantly checking if the data is conform to a certain protocol, like the data is fresh, then it starts its job. Why the sync all syncing into a single tick?
Because for example, if these two routines are not synced by the ticker, it could fetch data at this time, and this guy could fetch data at this time. But the simulator, how to make a determination?
Oh, so you mean simulator has to have exact same?
Yeah. These three guys are synced by ticker together.
So the price data has to be exactly the same time.
Yeah, same time. So you can make a decision in time.
Oh wait, so you're saying the simulation has to work if only if and only if the price are all on the same time.
Yeah, all in.
So what if one of the price is not available? What happens then?
If not available, just it just get nothing from the.
Now again, you could just use a conformed. Okay, and then that's pretty much.
You could have, in your information you're sending to the channel, you identify the source. And so at the other end, he keeps checking to see if there's something readable. He doesn't block, he just checks to see if something's readable, and he pulls stuff out. And then after a certain length of time, he could say, I think that one guy is dead, I'm not gonna wait for him.
Yeah, I think
You could do things like that.
I'm doing that way. Actually, for example, there are two guys that send data to the simulator. For example, if this guy is done, actually by the end of this time, the simulator only gets one data, and it's okay. It's totally okay for the simulator. So it just make a decision based on only one data. So the next problem is the React chart. About the React chart, here is what I'm trying to build. First, I have a chart grid. The chart grid will host nine line chart, and each line chart it's like a tree structure. Each line chart inherit from the tree node, and each line chart is actually represent exchange price. So for example, I have fetched 90 data. I have fetched the data from 9 different internet expression. So I have 9 chart to display them separately. So here's the process how Reactor works. First, the tree root will periodically fetch the data from the node server. If it fetches the data, then it will set its state with the new data. When the set state works, it will automatically trigger the render, and the render will render the React component here. And actually, the React component is a child of the current grid. So it will go down to the child component. So the child component is the line chart here. So each line chart will get the new data through the proper price here, and it will set its own new state. Then the same process will trigger the rendering and draw the line like here. So let's see the demo. First, okay, my node server has already done, and let me run my GoBot, fetch the data from internet. So here's my Go client start. It will fetch the data from internet and put them to all those Go routines, and then this data will flow to the Node.js server. Okay, So the client has already posted the data to Node.js. So let's check the data from the internet, from the browser. All right. So here is only a simple demo that until now I haven't finished the chart grid. I only finished the line chart. So here's the line chart component, React component for the Coinbase exchange, I think. So you can see every 6 seconds is a cycle. Every 6 seconds, the data will be refreshed here, and we can check the console that all this JSON data is fetched better.
So what we're seeing is near real-time variation in price out of that exchange. Right?
Yeah, real-time price. Yeah, right. So here's the real-time price, and like this. The lower one is the bid price, and the higher one is the ask price. So okay, let it running, and here is arbitrage result. With the ideal is that there's a zero delay, zero non-working delay. And here is the delay. The delay I hard coded it in my Go client. The delay I set it up as 1 minute. So after 1 minute delay, let's compare. Actually, the delay make more make more profit. We can have a look at the data from here. Each one is a tick data, and the tick field has all the data from 9 exchanges like Coinbase, apps, and each of these data include the ask price. Okay, that's basically. That's basically all the demo I want to show you.
So the real model behind all this is we have these sources of exchange. You can buy and you can sell. I'm not saying that's what you're doing, but that's the model, right?
Yeah, that's the model.
You can buy and you can sell.
Yeah, can buy.
And so what we're trying to do is to so ideally, if everything stayed static, you're guaranteed to making money because you're going to buy from the low guy and you're going to sell to the high guy.
Yes.
And the problem is that they keep changing.
Yeah.
So the longer your delay is, the more likely it is that you won't make money. Right?
It's just
because they're changing. So your decision was wrong. Right?
The longer the delay, it's actually the result is more unpredictable.
Yeah. Right. Exactly.
Yeah.
So what you're not really representing the sellback. You're just trying to see for various levels of infrastructure latency. How does my reliability change in that estimate? Right.
Yeah.
And that's fine. So there's really one more part. Were you to build a real product, try to make money out of it, there's one more part you got to build, and that's the sell. And of course, you have the same problem with sell because when you're making a decision to sell, there's a delay in how long it takes to sell, and that may change the whole game all over again.
Yeah.
Okay. Yeah. Do you have any idea how, I could see an exchange willfully making the sell time, the sell latency fairly long, so that they could rake off some.
As far as I know, many exchanges will limit your buy and sell rate. They won't allow you buy and sell.
Cool. Good. So now you have Go doing what you wanted to do based on that last conversation we had, right?
Yes, I have all the parts done except the React.
Yeah. Well, you've got React started.
Yeah,
I mean, we were seeing the real-time flow on that one chart. Now you've got to assemble it in the multiple charts. But basically, you're interacting with React and it's doing what you want it to do.
Yeah.
You know, what you're doing is interesting. You're not telling us clearly enough in your summary what you found, okay? I had to ask you, you know.
You mean in the Go concurrent?
Yeah, I think you ought to have a summary that says, so here, you know, Go is now doing what I wanted to do, and I'm satisfied with that. And React, React is doing what I needed to do for one of the graphs. Now I simply need to assemble that into a set of graphs. Something, you know, some really clear statement of where you are.
Yeah.
If you presented to the, you know, your venture capitalist who's giving you money to support this product, he'd be really upset right now because you're not really telling him where you are. Okay. But, you know, interesting piece of work, and you're assembling lots of different stuff. That's cool. Thank you. Any other questions? Yeah.
I have a question. I'm curious about the simulation part, and I'm curious. How do you do this simulation? Like, you use you write a simulation program, or you use some third-party simulator, like without doing the actual mining, just generate the transaction results.
Actually, in the transaction part, I actually did nothing. I just fetch the delayed price again and compare them with the previous price. And
Please give me a data.
He's trying to understand how, you know, with different delays, how is that going to affect my reliability? And so he's just delaying and then comparing. So, you know, if he made a decision on the data back here, now knowing the current back, was that a good decision?
Okay.
Yeah, actually, you can do that. But for me, it means a lot more work, because if you want to use the exchange trade API, you have to set up an account in that exchange. So 10 different exchanges means I have to set up 10 accounts. It's too much for me.
Yeah.
Please give me a data, like in the real world, how frequent, like how the price change.
So long as I know that it will definitely make a profit if the delay is not too long. You will definitely make money from it.
You know, there's a reason there's all that cryptocurrency hijacking. You know, they're using your machine to run your GPUs to, you know, to do their evaluation. So.
So I think you mentioned that you basically hard-coded the simulation delay.
Yeah.
So what that means is that you assume that if the transaction goes through, it will have a 1 minute delay.
Yeah.
So what is the ideal delay in the? I remember it's 1700. Is that seconds or?
I'm sorry?
The simulation you're running, I remember the ideal delay is somewhere around 1,000 and several hundred. Is that in seconds?
That wasn't delay, that was what he would make.
You mean the number in the demo?
Yeah.
Oh, the number, the refresh number means how much money, the price difference.
That's the price difference.
Price difference.
Oh, okay.
So he was a little embarrassed that when the delay got longer, he made more money.
Yeah.
He shouldn't have, but you know, that's just statistics. But I think what's happening with the crypto miners is that they are building probability models of those variations. That's why it is pretty intensive computation. So they're pulling the data out and building probability models and basing their decisions on a base, on a probabilistic basis.
Yeah, but that's the same with any kind of arbitration. All right.
Yeah, it takes quite a bit of computation because building those models and what you want is you want to be able to build those models in real time, but you got to process quite a bit of data to make the model reasonable. So what these crypto hijackers are doing is stealing your GPUs, using your GPUs to do some of their probability model calculations.
I thought they were just mining straight from your GPUs. Right?
I don't know, I don't know the ins and outs of what they're doing, but I think what they're doing is building probability models. Why would they need to hijack your GPU if all they're doing is grabbing the data and look at, they're doing something that takes intensive calculations, and what sure would make sense is to build a probability model. But that means that their models are constantly changing because the data is constantly changing. Okay. So the probability model is really modeling what's going on in that economy, not what's going on in that site. It's what's going on in the economy. It's just my guess is what's happening. I can't see why they would hijack anybody's GPU if they weren't doing that. Thank you. Okay, next time we will hear from, on Tuesday, we'll hear from Arash and Ruchika.
Shall I go first?
Is it okay if he goes first?
No, I was just asking.
You're first on the schedule, so yeah, you go first. If you come late, you'll find him going first. But, go with that. It's got to be quick.
But I should have somewhere else because I want to say no. 1, 2, 3, right?
I'm not sure what. I think what I think does is just another way to write those promises instead of.
What you're saying is fine. You want to say it a little more.
Catch the other is just
Getting out a lot of words. You can say it in very few words. What you're saying is fine, but you're using too many words to say it.
1, 2, 3, and I want them.
I'm graduating from a competitive program. We have lots of intense projects, and I've been doing well in it. So I think that means I work well. Okay. Nice.
I was trying to follow what you told me earlier, but I forgot.
Can't wait for the first one.
I wouldn't say salary is not my primary focus. I just say I'm more interested in the work I'm going to be doing than the salary. Really quick. But I want to be treated fairly. You got 2 points to make. The kind of work I work on is most important, but I want to be treated fairly. So yeah, so I expect to be paid, salary consistent with the position of in this location. Hey, if you try to come, you'll sound scripted. You're spouting out this memorized thing. You want to make it really short and sweet. But what you're saying is okay. Just
salary is
very direct.
Then the result will be, I guess,